స్టార్ట్ చేసాము లింక్ ఎట్లా
ఏడ పేసారు
అని కట్టు కట్టు అదే అదే కూడా సరిగ్గా వచ్చిందని చెప్పి ఏంటి ప్రాబ్లం ఏంటి కన్ఫర్మ్ చేసి అందరి పేరు చెప్తే రిజల్ట్ కాల్ బ్యాక్ చేస్తారా సరే కాల్ కట్ చేస్తా మళ్ళీ చేస్తాను కథలు పెట్టి మూమెంట్ లేచి ఒకసారి లేచారా
వీడియో ల్యాగ్ ఉందిరా
వీడియో ల్యాగ్ ఉంటుంది ఆబ్వియస్లీ ముందుసారి కూడా ఏం పర్ఫెక్ట్ గా రాలేదు వీడియో
ఇగో
పక్క ల్యాగ్ ఉంటుంది వీడియో నువ్వు లైవ్ పెట్టేది లాగ్ ఉంటది లైవ్ అంటే పర్ఫెక్ట్ లైవ్ రాదు
లే బ్రేక్ అయితే చాలు ఇంకా కొత్త లింక్ రజత్ చాట్ లో ఉంది షేర్ చేసుకో ఇది యాంగిల్ సిటీ
హలో నువ్వేనారా పోస్ట్ చేసే కామెంట్ చేసింది సరే
కెమెరా
తీసండి వద్దు వాళ్ళు చేయండి వాళ్ళు క్లబ్ వాళ్ళు తీసుకుంటారు
కెమెరా ఇంకల్ పెట్టు కెమెరా ఇంకల్ పెట్టు
లాగ్ ఉంది తెలుసు వస్తుందంట్రా
కొంచెం పైకి పెట్టు మధ్యలో పెట్టు
ఓకే యాంకరింగ్ కనపడదు కదరా ఇంకా వెనకాల రాల ఇక్కడికి రా ఇక్కడ కూర్చో సెకండ్ రో ఇక్కడ ఫస్ట్ టీచర్ ఇప్పుడు చెప్పు
ఇది స్ట్రైట్ కొంచెం మీకు రైట్ వచ్చాయి ఉంటాను
ప్యాంట్ కనపడద్దా?
స్ట్రైట్ పెట్టు ఇంకా
స్ట్రైట్ ఉంది.
ఇది స్ట్రైట్.
ఓకే
ఇంకా అటు 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 హైట్ నుంచి
చాలేరా సరిపోతుంది. చేతి తీసేస్తా సరిపోతుంది. మళ్ళీ సరిపోయింది సరిపోయింది
అటు నుంచి
సరిపోయిందిరా. ఈక్వల్ ఉంది.
ఓకే కొంచెం కొంచెం
సొట్టకుందిరా. ఇంకొక ఉందా కింద చూడు. కొంచెమే కదా మళ్ళీ లైట్
అట్లా అనుకుంటే
చెప్పరా చెప్పు. నేనేమో వెనకాలకా చాలేరా సరిపోతుంది. నువ్వు యాంకర్స్ ఎందుకు కవర్ చేసేస్తాను? యాంకర్స్ అసలు కనపడుకోకుండా చేస్తాను.
చాలు చేద్దాం.
చాలు వదిలే గెలకద్దు.
Hello everyone, a very good morning. It gives me immense pleasure to welcome you all to the celebrations of the 3rd National Space Day 2026, organized by the Department of Electronics and Communication Engineering, CBIT, Hyderabad, in association with Ham Radio Club, CBIT. A very warm and enthusiastic welcome to our respected dignitaries, distinguished guest speaker, faculty members, scholars, students, participants and all space enthusiasts gathered here today. Today is a very special occasion. We are celebrating the 3rd National Space Day of India, commemorating the historic achievement of Chandrayaan-3's successful soft landing on the lunar surface. But National Space Day is not merely a celebration of historic achievement, it's a celebration of India's continuing journey towards a technologically advanced and developed nation. And therefore, the theme of this year's celebration is India's space journey towards Viksit Bharat 2047. This theme reminds us that India's achievement in space is not just milestones in science and technology. They are stepping stones towards the larger national vision of Viksit Bharat 2047. Space technology today touches almost every aspect of our lives, from communication and navigation to weather forecasting, disaster management, agriculture, remote sensing, and scientific research. And the future of space technology is becoming even more exciting with the integration of artificial intelligence, advanced electronics, intelligent communication systems, and next generation antennas. And today, we are privileged to explore one such fascinating area through our special guest lecture on trends in AI, space antennas. So let us begin this celebration of India's space achievements, innovations, and aspirations for the future. Now we are moving from ideas and words to innovation and experience. Under the guidance of Dr. Vasant sir, we had the wonderful opportunity to be a part of the winter upskilling course on nano satellite design. It was not just a course but a journey where we explored the fundamentals of nano satellites, understood their design, and got a glimpse into exciting world of space technology. The video we are about to watch takes us through this journey. So let's take a moment and look back at our journey and relive those memories. Let's have the video, please. for taking us through those wonderful memories and experiences. A successful learning journey is never just about what we learn, but also about the guidance, encouragement, and people who make that learning possible. We are fortunate to have with us someone who has always encouraged students to explore beyond the classroom and embrace new opportunities. To begin this wonderful event, may I now request our esteemed dignitaries to kindly grace the dais. It is my privilege to invite our distinguished guest speaker, Sri VVSRN RAJU Sir, Scientist F, DLRL Hyderabad, to grace the dais. I respectfully invite our Principal Sir, Dr. C.V. Narsimlu Sir, to kindly come onto the dais. I invite our head of the department, Dr. K. Vasan Sir, to kindly come onto the dais. I also request our esteemed faculty coordinator, Sri A. Krishna Kumar Sir, to kindly join us on the dais. May I request everyone to give our dignitaries a warm round of applause. Every great journey begins with a spark of knowledge, inspiration, and curiosity. To mark the beginning of today's enriching event, let us illuminate the lamp, symbolizing the light of knowledge that guides us towards new possibilities and discoveries. I now invite our esteemed dignitaries to kindly join us for the ceremonial lighting of lamp. May this light inspire us to learn, explore, innovate, and reach beyond the ordinary. So everyone, let us all welcome this auspicious beginning with a big round of applause. We now have the privilege of hearing from the person whose leadership continues to inspire our institution towards excellence and innovation. I warmly invite our respected Principal Sir, Dr. C.V. Narsimlu Sir, to address the gathering and share a few words with us.
Good morning to Honorable Guest Speaker of today's National Space Day. Conducting guest lecture on trends in AI-driven space antennas, VVSRN RAJU, scientist at A level, and your head of the department, Dr. Vasan, and faculty coordinator, Krishna Kumar, other faculty members of the department, and my dear students. Once again, good morning to all. So this is an auspicious occasion. So tomorrow we are supposed to celebrate the National Space Day. Tomorrow happened to be a holiday. That's why one day in advance we are conducting. Right? I appreciate the department and faculty coordinators for taking forward and conducting the national events of commemoration of these kind of things. And just now I have seen the exhibition. Some of your friends have developed, designed, and exhibited their thoughts. So now this is the real engineering, which is different from classroom, not like a mundane activity routine, taking inputs from the faculty members, lectures, and writing examinations. It is one kind of thing. This is the real engineering where you are involving and exhibiting your talent and designing and developing and showcasing. So this way I appreciate all of you for coming forward to participate in these kind of exhibitions. I also appeal and request, motivate you all, not only in our college, you also participate in this kind of exhibition in the entire nation and international participation. We are here to help you for your any equipment or any other things also, logistics also, institution will take care. You need to represent the CBIT in the national forum and international forum in these areas. Right? Will you do? Will you come forward? Yes.
Louder.
Good. Okay. So I also thank the VVSRN Inspector of the Busy Schedule. Now he is gracing our occasion. Thank you, sir. So for your gracious presence here. I also appreciate the faculty coordinator and particularly head of the department. So since 3 years I have been observing, he is very interested and passionate towards the satellites and all head of the department. So we are all very fortunate to have these kind of things. So he will guide you. Some more students also. I also request you to guide some more students, not to represent the CBIT in the national forum. Right? So that is the main target. And not only this, even other areas also are equally contributing. Right? So you all know now the placements scenario has entirely changed. Right? There is a paradigm shift in the HR's thought process. Right? Now it is skill based, not like a CGPA based or percentage based. So I used to tell these students in the last year, they think 24 and 25 batch in IIT Madras, the top placement in the IIT Madras itself was gone to one student who is very good in extracurricular activities, not good in the academics. Right? So there are certain proved examples are there. So you need to improve your skills, including your communication skills, leadership skills, interpersonal skills, logical thinking, critical thinking. These are also matters. These are also life skills. So the person who achieves 10 CGPA, if he is not having good skills to communicate or to maintain his own, his own colleagues or family members, there is no use of achieving 10 CGPA. Right? Attitude is also more important. Right? So besides your academics, you have to develop a good attitude, good personality, then you can become a successful person in future in your life. Right? So with these few words, so I have another meeting. I request sir to excuse me. I will leave. Okay. So I wish you all happy Space Day, National Space Day. Thank you.
I kindly request our principal sir and HOD to kindly felicitate the speaker, VVSRN RAJU sir. Give him a big round of applause, please. Now I invite our respected head of the department, Dr. K. Vasant sir, to share his thoughts and addressing the gathering. Sir, we look forward to your words. The stage is yours.
Morning all, actually. We've been planning for this event for the last fortnight actually. We want this to happen and this is one such event government has taken initiative to celebrate. There are a lot of space activities, space exhibitions they conduct, but all are government-based organizations actually. What did the department, that to an engineering college level, could contribute to a National Space Day? That's the first question. And why are we celebrating this event in the department? That's the first and foremost question. For this, the plan was devised in the last September, sir. And there is something called winter upskilling course was conducted. Okay, in collaboration with the NCRC lab, we have a navigation communication laboratory. the coordinator is Dr. Shiva, and in association with the ham radio club of the department. Okay, we have a ham club in place, licensed to operate on a particular frequency. Coordinator is Mr. Krishna Kumar sir. Along with the club, we rolled out with a 135 hours session on nano satellite design, actually. You could ask me what is so super about this course, sir. First of all, this course is not offered in anywhere in America. Right. Second thing, you need to learn engineering to do this. Whatever you've seen there, those are not just models. Those are the discipline of engineering. Right. Anywhere you learn embedded systems, you connect something and you get some output. That is not engineering. That is just electronic assembly. There is always a difference. Okay, what we do is like there is a sort of discipline where you try to develop any sort of models, either in terms of automotive electronics, or in terms of consumer electronics, or in the place of defense, or in the place of space. See, ISRO is not a quality policy. The name of the quality policy is nothing but zero defect in space. That means they don't put the junk or non-operating electronics in space. Okay. In that regard, we have to be very careful, and the process of engineering is what is very much required. Not just you do simulation, you do some hardware building, it comes out with a prototype model. Whatever models we have developed here are all of TRL level 3 and above. 1:1. Okay, well, you cannot find these sort of projects anywhere. In any engineering colleges of Telangana, I mean, one more point to add, even in IITs and NITs also. So your faculty, your student who is around you, the faculty around you has helped them to build a system of this sort. Okay, you know, next question me write, sir, what is the outcome, sir? 30 students from second years and third years have undergone 135 hours of lecture, both online and offline, industry experts, traveling to industry visits to learn to build the satellites. Once they completed, we have requested them, we have given 2 months time for them to build a hardware. The outcome of that is this exhibition. Okay, you may think department has not worked in any other area, sir. So this is only satellite, sir. Still we have VLSI, still we have navigation and communications, and we have signal processing, and still we have real-time operating systems, embedded systems are also in place actually. So these many courses, around 218 students got benefited because of this. Only 30 are disseminating. Another 180 they will disseminate on the concerned flagship day. This is one such flagship day actually. What happened? What this knowledge has given forward? we spoke to companies such as Red Balloon, right? Rodrigues, okay? Then Skyroot and Sansi. These people are pioneers in military and space. 5 of our students have already got internship through this, and few rejected the offer. The people who are sitting here have taken up the interview, they rejected the offer. They don't want to work in this particular area as they have to travel to Vijayawada to work actually. Look at the quality. The company is offering, students are not willing to work. Look at the 135 hours of magic what it can do. Meticulous learning process. Few more companies are invited, companies such as Xgenix, okay, Skyroot are on their way. Soon those people will come for the recruitment. Of late, after talking to the HRs of the company, I have understood one point, hereafter it is not the easy engineers. Okay, hereafter it is not the easy engineers. It is RF engineer, it is an ADCS engineer, right? It is a mission management engineer, orbit planning and management engineer, likewise job specific roles in core. That is the reason why those students have got jobs. Even you will also get a job, you will have your own particular opportunity. See, this work was done with a lot of passion, lot of sleepless nights, a lot of scoldings to the students. It was never a smooth transition. We gave all our best to demonstrate that. Still we go a bit higher. We have demonstrated a 1 new class spacecraft in the department. Maybe in a month, we will put it onto a balloon experiment and the data will be received through that. Finally, there is a saying in Tamil literature called Thurukkural. Okay. Yagam Ayani, that's a word, it starts with. That means that you choose an area Okay, you choose an area, you fail again, and again. You build your expertise. Then you showcase to the world that you are an expert out of it. I believe in that very strongly. I have demonstrated. I am waiting for an opportunity that one day India might need us. We don't want assemble in India. We want made in India. For that, students are being built up. I am training. One fine day, this country might need help. By then, Vasan sir might have got old. But the knowledge, the seeds of knowledge what is shown on you will be the face of Vasan sir in helping the country. That is my dream. That's what I wanted to happen also actually. That will happen. And these are the activities what we do in the department. Right? It is far more immense. Right? Quite imaginable, unimaginable in other states or other academic institutes of the same policy actually. So once again, I request all the students to come out, participate in large numbers in activities of this sort. Don't be idle. Don't be idle. Trying, action is the most strongest word. Showcase yourself. Don't sit yourself. To course this you can also select your own job, select your own company, career of taking your life forward actually. Right? I would like to thank NCRC coordinators and Krishnamurthy sir, and three of the instructors were there, Dr. Vivek Singh Joshua and Dr. Shrikar and Dr. Neeraja for helping out with taking classes. Two technicians, Seshikar Rao sir and Basanti madam, were part of this particular entire activity. Apart from that, there are many more known, unknown people who are part of this activity while traveling to the companies, while demonstrating here in the ground. Anyway, it is not that we speak engineering, we do engineering here actually. Right? Once again, I thank the organizers for giving us an opportunity to excavate what knowledge levels we possess. Together, we grow. Right? God bless you all. Right? Don't step aside. Keep trying. The winning is always on our side actually. Thank you. Thank you, sir. Happy National Space Day.
Thank you, sir, for those valuable and inspiring words. It is now my pleasure to invite Dr. K. Krishnakumar sir, Faculty Coordinator of Ham Radio Club CBIT, to share his valuable thoughts and insights with us and to introduce our chief guest. Sir, we are honored to have you us today. May I request you to kindly address the gathering.
Respected Chief Guest, VVSRN, Scientist of DLRL, and our young and dynamic Head of the Department, Dr. Vasan, and my dear students. It's a very good morning. So, I am A. Krishna Kumar, the Faculty Coordinator of Ham Radio Club. So, this Ham Radio Club started in the year 2023, recently, like 2-3 years back. So we started this Ham Radio Club to introduce, actually, this is a hobby club. Ham Radio Club is a hobby club. So where the students will explore the things, designing of antennas. So actually ham radio, what is ham radio or amateur radio? Ham radio is wherever there is no network, the ham radio will work. That is what the concept of this ham radio. So no signals, this ham radio will take care to communicate. So national disasters. So if a disaster will happen, so no signal will be there. So there the ham people will do the rest of the things to communicate or to help the people. So on this concept, so why not we introduce the ham radio club, then the thought came out. So we introduced this ham radio club. It's like a hobby club where the students will design and receive its own receiver and transmitter designs. So this requires to qualify the exam. This is conducted by the Department of Information Technology, Government of India. So where we need to test, they need to test some signals like basic semiconductors and signal mechanisms. So there we need to pass the test exam. So once we pass the test, then we have to apply for the license. So then we will become a ham. So you can operate the ham, or you will become a ham. You can operate the signals within a limited frequency band. So that is what the process for becoming a ham. So now next within 2-3 months, also within 2-3 months, we will planning to conduct this type of ham radio exam. So already we conducted twice. So once again we try to conduct the exam for that. So I request all of you to write the test. So we need to apply. Before that we need to apply. So through our ham radio club, we help you to apply that. And also we see that test center will be the CBIT only. So in the CBIT itself, we will be writing the exam. So we will help you to pass that exam. So just our HOD sir is also trainer, ham radio trainer. So he will train us. He will train you people to get past the exam. So this is what we start ham radio club. So obviously, so you might have seen the video. That is what our dynamic HOD. So he is very much interested in these satellite designs. So with the help of HOD and with the help of ham radio club, we will look forward to more and more designs in the coming future. As comes to our guest speaker today, so this is my honor to introduce our guest speaker. So VVSRN RAJU garu. So VVSRN RAJU garu is completed MTech and joined as a scientist in Defense Electronics Research Laboratory, a center of excellence for the design and development of electronic warfare system under Defense Research and Development Organization, Ministry of Defense. For the last 17 years, he has played a key technical role in the design and development of signal processing algorithms, digital electronic intelligence receivers for the various land, airborne, and spaceborne projects. He played a pivotal role in the design and development of digital electronic intelligence receiver for India's first space-based elite system. His specializations and research areas include development of optimized radar signal processing algorithms, miniaturized electronic warfare systems for the unmanned and space-based platforms, test and evaluation of EW systems. He is a recipient of Technology Group Award in 2012 and 2019, and a DoD Award for Prominence Excellence in 2020, and has published many technical papers in various national and international conferences and journals. Presently, he is serving as a scientist F and is a project director for one of the ongoing projects. We will welcome you, sir. Give a big round of applause to sir. Thank you for the opportunity. So we look forward to this lectures. Thank you.
Thank you, sir, for your valuable insights and wonderful introduction. We have all been waiting for this moment, the opportunity to learn, explore, and look at the world of technology from a new perspective. I now invite our esteemed speaker, Dr. VVSRN RAJU, sir, to take us to today's guest lecture and share his valuable knowledge and experience with us. I'm sure this session will leave us with not just new information, but also new ideas and inspiration to explore further. So please put your hands together and welcome our speaker once again. Over to you, sir.
Fine. Very good morning to all of you. I'm very happy to be there with you today. So it reminds me maybe around 20 years back when I am also sitting like you and listening some guest lecture which has sparked something. All those things are coming on to me. After so many days, I came to this kind of forum. Though I had a interaction with students regularly in a different forum in a different community. It's the first time I'm coming as this kind of lecture, that too on a National Space Day. And first of all, I must congratulate CBIT and particular Dr. Vasant sir in taking you through the journey of space through a course wherein you might have learned the practical aspects, whatever are there. With reference to he has taken a theme of nano satellite, and with that one, he has tried to do this one. He has already spoken some points on how this can be useful, what you will do, what is the course of this thing. So, I will connect all the dots, whatever you have, some doubts, all those things. You are free to interrupt anytime, okay? So, yeah, I will make it a more and more interactive rather than to somewhere, okay? So before we start this thing, the formal presentation we will have this thing. For that one, we will try to put it like how whatever you learned in the college, what you do outside. So where is the gap? Now there are something So when you study something in the college, in the textbook, okay, and you want to implement something on the ground, where the gap will come, how to fill that gap, all those things I am going to address on this thing. Though the topic is given as a trends in AI-driven space antennas, I have chosen a topic, a broader topic, not only restricting to antennas, covering the entire spectrum of different subjects what you have studied and how it can be used in the actual. So today the topic what I have seen, I have taken is observation from the space. This is the theme of ISRO this year, what they have taken. And for the National Space Day, why it is celebrated, all those things you already know. This is commemoration of the Chandrayaan landing on the moon on 23rd of August, which we are celebrating. This is the third year, 2023 it has been launched. So now, what I am going to take is, what is the electronics and communication engineering technologies which are there behind the modern space missions? Okay. So, what you have studied all these years, how it will translate into a system. So this is what we are going to do with this thing. So, before that one, I want to start with one thing. Like how a systems will be built. What is the basic where we will start? Okay. So you have different branches in the science, correct or not? You have science, you have engineering, you have technology, correct or not? So can any of you start with that thing? What is science, engineering and technology? So you have in the same college you have computer science department, correct? You have electronics and communication engineering, you have information technology. Why something is called science, something is called engineering, something is called technology? Is there all are same or any difference is there? Huh? So can anyone just a random what you have this thing? Okay. Have any of you thought of this thing? Why computers
when it comes to the branch, it is called computer science. When it comes to electronics, it is called electronics and communication engineering. When it comes to information, it is called information technology or satellite technology or radar technology. Different things are there now. So what is the difference? If you understand this difference, first, this will be the first stepping stone into a area of research where you would like to explore the things which are behind the screen. Okay. See, if you see science, when you study, when you start your study, you will study only science, no? Science is about nature, correct? So what is existing in the nature, what is true, what is already existing, that when you are exploring, it is called science, correct? All of you agree with me or not? Correct? So that is why when you are in the childhood, you start with the science. Then when you come to some higher classes, the science you will make into physical science, natural science, so many things you will do. Then you study physics, chemistry, different things. Now you came to engineering, correct? So when you come to engineering, why it is called engineering? Okay? So engineering is something wherein you are using the science principles behind the science and you are trying to engineer a product or you are trying to do the same thing which is done manually, correct? So a simple example, I will start with that thing. Now you might have studied all of you studied Archimedes principle, correct or not? All of you might have studied Archimedes principle in your college. So it is a weight and counterweight. Basically, if you see as a simpler thing, okay? The same thing when it comes to taking water from a well, people used to put some kind of something and take the water, correct or not? So then what they have done? Because it is a laborious job where you have to do, they have used a pulley, correct or not? So where the weight which you are doing is reduced, okay? This is what is called engineering. The same engineering, if you see in the lift, when it going, when some weight is going up, some weight will come down in the lift, correct or not? You have seen this thing? So this is what, where you are using this engineering principle and making it a bigger thing to make your life simpler, correct or not? Earlier also you are going up, now also you are going up. Rather than steps, you are going through a lift, correct? So this is what is called technology. Application of engineering principles to make a product is what you are calling it as technology. Okay? So now you might have understood the difference. Why computers is called computer science? Because you might not have studied that thing and you are studying the basics of the computer from the beginning. So that is why it is called a computer science. When it comes to electronics, you have studied something of electrons. You have studied something of the electronic motions, all those things. Now you are starting with the engineering principles, correct or not? So once you have done the electronics engineering, you will become a technology people where you will use this technology to build something. Okay? With this starting words, I am starting. Okay, next. So today I am going to cover why space touches everyday life. What is a satellite anatomy? And subsystems where electronics people have got their cup of cake where they can do this thing. And the space electronics, why it is different from the commercial electronics, why it is different from the industrial electronics, what is the design philosophy? If you have to put something onto the space, how you have to make the system, what are the best practices, and what are the careers and space entrepreneurship which is there, and what is how your syllabus is going into the orbit. This is what I am going to cover. Okay. This presentation I made it curated using Anthropic AI to match your thing. Okay. But I will answer one question at the end. So beyond AI, what AI is doing already, what beyond AI where we can contribute. Okay. That point, one practical example I will cover also in the end, wherein you will get this. Okay. So coming to this thing, so there are different applications of space. Broadly, there are different things are there. One is a communication application. Let us suppose you are seeing a TV, you are using your cell phone. Everything what is happening. So from your phone, it will go to some base station. From base station, will communicate to a satellite, which is a GS internet. And again, from that one, it will come to different base station, and it will come to your communication. Okay. Now, relay around 36,000 kilometers. So, when you are traveling this much, how this is happening? So, meanwhile, when I am explaining any concept, I will take you to some examples wherein you can better appreciate the principles. Okay. Now let us suppose from now I am calling from here, I am calling to Dr. Neeraja. So the call will go to a space antenna and it will come back, let us suppose. So how much time it will take to go to 36,000 kilometers and come back? Can any student can tell this thing? So just you have a wild guess.
You can guess.
Anybody?
It may be wrong or right. No issue at all.
No issue. What I am going to tell you is how you have to look at the principles what you have studied. So all of you have studied electromagnetics, correct? What is the speed of light? 3 into 10 power 8 meter per second, correct? So that means whatever concept you are studying, see, if you have to build systems, whatever you are studying, same thing you have to understand in a slightly different manner. Now, if I say it is 3 into 10 power 8 meter per second, I will say it is 3 into 10 power 5 kilometer, correct or not? So that means 3 lakhs kilometer electromagnetic wave can travel within 1 second, correct? So when you have to 30,000 kilometer, when something has to roughly, how much time it will take? 3 lakh, some millisecond, correct or not? So that is why even though you are communicating over this space also, so rather than taking this route, we are going to space and coming back, correct or not? So within that much delay, within that millisecond delay, you are able to get it because it is done through electromagnetics. Now you understood the power of electromagnetics. Otherwise, what will happen? Normally, electromagnetics is a boring subject. People want this, what is E plane, H plane, Poynting theorem, Maxwell equation. Okay. So if you try this way, first you have to understand the power of that one, then you will fall in love with that thing, how this is happening. Okay? Got it? Fine. So now there is a navigation in there. Now whatever maps you are using as on today, different maps, is all based on the satellite thing only. Correct or not? So it is not only on the roads, on the ships, for the aircrafts, so many things. Navigation is getting used. Correct or not? Now we have a remote sensing. Somebody will say today prediction of the weather, what will happen, what is there at some place, what is the land profile of one particular area, how the sea is behaving today. So all these things comes under remote sensing. Okay. So these are the different applications where satellites will fit into it. Now coming to planetary exploration, where Moon and Mars mission, deep space missions, whatever, these all comes under planetary exploration. Okay. And there are defense applications of this space where I am specialized into this thing, wherein this border surveillance, then early warning, guidance, detection of the enemy signals, all those things, what they are speaking, if you have to monitor through the space. Okay. If you know what the other person is spoken over their radios, their phones, if you can get that one, you will get so much of information in the Varna. That is what is done for the space defense. Okay. So there are different areas are there. So I will tell you, now I will ask you some questions on this thing. It is a simple thing, do not think anything complex. Whatever you have studied, all those things only will be there. Okay. When I say communication satellite, where it should be? Why it should be at 30,000 kilometers on the top? See, all might have studied. Why?
Yes or no?
Tell, no problem.
It covers the
Huh?
covers the everything.
It covers the earth. Very good. Right? So you came to a nearby answer. Okay. So what I will say, I am staying here, I can see your room. Correct? If I go to the building, I can see the entire CBIT. Correct? If I go on an aircraft, I can see some area in and around the total outer ring road or something if I go to that height. Correct or not? So if I go to 36,000 kilometers, it can cover 1/3 of the earth. Correct or not? Are you getting? Okay? That is why all the communication satellites are on the geostationaries. Okay? So, all the communication satellites, why they are in the geostationary is because the moment you go up and down, this is the same principle. If you understand the principle like this, you will not think that this is a different area what I am seeing. Okay? So if you go to 36,000 kilometers, you can see 1/3 of the earth at one time. Okay? Like that, you are seeing different areas to cover the entire earth. you require minimum 3 satellites. This is what you study in your satellite communication course. Correct or not? So that is where the communication satellites will work. Okay. If you want a navigation, how you will do? So if you see from 36,000 kilometers, what is the trade-off? What you will have? If I see from here, I can tell Dr. Vasanti is there. Some student is there here. There are 100 students are there. I can give the resolution. Correct or not? There are 2 students sitting here. But if I go up and up, is it possible to give this kind of resolution? You will not be. Correct or not? So what navigation satellites and remote sensing satellites, wherein you have to observe some area. Correct or not? So if you want to observe your area, you need to put a satellite not at the 36,000 kilometers. You need to put it at a level wherein you can see that thing with a good resolution and take the photograph or whatever you are doing. Then use your algorithms, different algorithms to analyze this data and do the map. Correct or not? So all navigation satellites and remote sensing satellites work in the LEO orbit. Got it? Now coming to planetary exploration. This is a completely different area than this one. Planetary exploration, where you have to see, you have to go to that planet only. Correct or not? So there you will send the required thing. How all these things I am going to cover. And when it comes to defense also, you need not go to very high or high. So let us suppose India, if you want to see, where you have to go? You need to see what is happening around your enemy territory. Correct or not? Around Indian region. So maybe Pakistan, China or whatever other countries, that is what one application where we will do. Okay. So we have a satellites covering from the LEO orbit, MEO orbit and GEO orbit. You might have studied all the 3 topics. So how you have to understand, if there are 3 orbits are there, why 3 orbits are there, what is the application of each of these things, where which satellite will go into which orbit, and what are the trade-offs are there. Correct or not? If you go higher up, you will not be able to get that. Correct or not? If I do a picture from here, camera resolution will be different. If I do higher, it's a difference. Correct or not? So how much you can process based on that one, that is the technology which will decide. Okay. So is it interesting or I have to go slow or I may need to make faster?
Suffice.
Suffice? So now you understood, no? So whatever subject you are studying, you have to understand why it is like this. What is the internal meaning of this one? Okay. Now coming to satellite communication. Okay. So whatever, that is why you are able to see the cricket match, whatever is happening with a minimum delay, because the satellite is going very higher up and it is going. Right? Next, navigation. So navigation, we have different countries are having different constellation of satellites. So navigation doesn't come from one picture. See, this is what I am going to tell you on this point. One point I would like to have here. So I say you have gone up to some 100 kilometer, 200 kilometer above. Okay. So there are some SpaceX has launched some constellation of satellite. There is US has got GPS, GLONASS from Russia, Galileo is there, India's Navic is there, China's RAJU is there. There are different constellation of satellites. What are these constellation of satellites where it is required? Now, if you are observing Earth, let us suppose some area from some 100 kilometer, 200 kilometer on the top. Correct or not? To get the map clearly, you need to have the different views of the same place from different areas. Got it? How the maps will work. Now, if I am seeing you, if I have to portray the picture of this person, I have to see this person from this area, from this angle, from the back angle, different angles will be taken. All this data will be merged together to give you a correct map what you are seeing in that one. Okay. So how our maps will be built is, there are a number of satellites are there which are monitoring the same roads through different angles at different times, and all this data is collected and that data is processed in a high-end servers to give you the exact map. So then only with that one only you will be able to say this street is there. Inside views also is possible because of this one only. It is not because of the only one satellite. Correct or not? You require different satellites which are working together. That is what is called a constellation. Okay. So which requires a precisely timed signal. Correct or not? Why it is precisely timing is required? So from which place you are going, see, from what angle, from here I am seeing, I am seeing you at a 30-degree angle. From here I am seeing you at a 0-degree angle. Correct or not? So if I have to get this information precisely, I need to have the precise time to get the position, because the satellite position you will come to know through its time also. Correct or not? Because satellite runs at a very faster speed. Correct or not? So what is the speed at which satellite is working? At a height of altitude of, let us suppose, 700 km approximately. Can anybody imagine? Or you know already? I think I have seen some people have done some, based on the Keplerian things they have done, orbital, how much time it is taking for one orbit. So it is around 7.6 km per second. It is around 7 kilometers per second. So if you see an aircraft, how much aircraft is traveling at one speed? 500 km per hour. Any commercial aircraft if you take, correct or not? If you have to go to Delhi, it will be around 800 km. You will take 2 hours, correct or not? So 400 km per 1 hour means 400 km in 3600 seconds. What you are going to do here with a satellite, what speed it is moving? 7.6 km per second. That means 7 into 3600. How much it is? Around 25,000 km per second is what is the velocity with which satellite is rotating in the orbit. Correct? So when it is going with that much speed, so by the time if your precision of time is not in millisecond, you will go to some other place. Correct or not? That is why this precision time is very much important. Okay. So you will collect the time data from 4 satellites to find out the position. Okay. So coming to remote sensing and earth observation, these are mainly for weather, for the radar based sensing, and for different kind of downlinks, wherever these are there, where you will find your space. Okay. Now coming to these things, whatever you are seeing, like different areas, like designing transponder, the translate uplink to downlink frequency, like what you have done, already you have done. So I am not covering much onto this thing. So somebody has done some uplink and downlink design also here. I have seen the project. So these kind of applications are there. What you have done is finding into a bigger system. This system is making its place. Correct or not? So you need a high gain antenna. You need an RF front end. I am coming to this thing. You need a ground station receiver. Any satellite you take, these all are things which are required, where you can contribute. I will leave the presentation with you. If you want, you can go through this thing. Now coming to deep space exploration or a planetary thing. Okay. Now whatever Mangalyaan you have seen, Chandrayaan you have seen, these all comes under planetary and deep space exploration. Okay. You want to see what is there on the planet, what you are going to explore with this thing. Okay. So they will send the different orbital and a rover which will go beyond the Earth and onto the planet to study what is there on that one. Okay. So presently you might have seen this Chandrayaan 3 has landed on the moon's south pole, and there are Mars rover missions have happened at different countries have done it. So to do all these things, I will come to these things where EC engineers are finding its place. Okay. And coming to defense and strategic electronics, where now let us suppose you want to see the enemy, what he is doing, where their forces are moving. Now let us suppose a war has come, recently whatever has come. If you want to see what are the, if you want to win a war, or if you want to attack an enemy, if you want to get advantage over enemy, what you have to get before the war? War is mostly about the strategy. Correct or not? So you should know where the fighter aircrafts are located, where the radars are located, where the tanks are located. Correct or not? You need all this information before. So if you have the entire map about the enemy, what they are having. So from space, you have a better position to get all this information than any other thing. Because once you are in the space, you do not require a passport. Correct or not? You do not have a border that you do not have the fear that your aircraft is once it is going, it will be attacked. Correct or not? So once you get the information where are these things are there, then you can plan your aircraft, fighter aircraft, then you can plan your troops there, then you can plan your land vehicles or sea vehicles, where to attack, from which place to attack, all these strategies. For that one information is required, which is coming from the space sensors. This is what is the requirement in the defense and space application. Okay. Now, if you see an anatomy of a satellite, okay, the satellite we have two things mainly. What is that one? One is the satellite bus, another one is the payload. Can anybody tell what is satellite bus and what is payload? This one, no problem. You all know that you are not coming out, okay, out of this thing. So satellite bus and satellite payload, okay. To have any body onto the space, you require a spacecraft. Correct or not? You might have heard of different words, no? Spacecraft, satellite, different words. All looks like same. Or launch vehicle, you might have seen different things. Huh? So what is the difference? Just you go through after going home. I will leave it to you. Okay. Then coming to the bus and payload, these are the two important points which you need to understand. Okay. I will come to this thing. A satellite bus is basically a satellite. Satellite is which will make the payload or the satellite revolve around the one what you call orbit. Okay. So this is basically defined by the Kepler laws of motion. Correct or not? So towards this thing, you have to put something. Okay. Now I will tell you. Now I want a TV communication. I want a communication network. What you have to put on the satellite? You have to put a communication receiver and a communication transmitter. Correct or not? Huh? Now you want to see the map of a place. What you have to keep? You have to keep a high resolution camera onto the satellite. Now, if I want to monitor the border, what you have to keep? You have to keep a sensor which is tracking the communication of the enemy, which is seeing the pictures of the enemy, which is finding out different signals, capturing different signals of the what are being received onto that thing, and it is revolving around the satellite. So now you understood the difference between payload, satellite and bus, a satellite and payload. So all these missions, whatever you do for all the applications, whether it is a communication application, whether it is a navigation application, whether it is a military application, or whether it is a Earth explanatory explanation, once the satellite is revolving in an orbit, it requires a satellite system, which is called the satellite bus. Okay. What you are seeing normally for any mission, satellite bus is required. Correct or not? Now we understood? Satellite bus is which keeps the satellite onto the orbit. Based on the, once it is in the orbit, attitude correction we need to do. You need to communicate from there. Satellite health you want, satellite positioning you want, navigation, all this information. These are all part of the satellite bus. What is payload? Which will pay you. What you are actually putting onto that one. Correct? Now if I want to communicate, I am using this one, this mic. This mic is a thing which is making me communicate with you. If I want to take a picture, I will use something else. I will use a camera. Correct or not? So what you are putting onto the space, that is what is called the payload. What is paying you, that is the payload. If you are taking a camera onto the top, then camera is the payload. Camera and the processing electronics is the payload. Okay? If you are taking onto the satellite a communication system, that is what is your communication payload. Okay? This payload will differ from one mission to another mission. Okay? The satellite bus is the one which is making your satellite to rotate onto the orbit. To keep the payload as well as the satellite onto the orbit is what is called satellite bus. Now we understood the difference between satellite bus and payload. So satellite bus is what you are seeing at the satellite, what you call is a satellite. So to put the satellite onto the orbit, you require a launch vehicle. Okay? So this launch vehicle, satellite bus, satellite payload, this entire thing is together is called spacecraft system. Now we understood the difference between spacecraft and satellite. Spacecraft consists of everything. Okay. Now on the satellite bus, you have a power system. Since you have taken a camera, you require a power system which requires some power. Correct or not? So since satellite mission, once you are kept in the orbit, it cannot come back. So you require a consistent power. Correct or not? So for that one, we use the solar panels, solar batteries, which will charge based on the solar panel thing, and it will condition. Conditioning means what is the power supply which is required for the electronics which is operating onto the satellite. So the first system what you require is electrical power system. Correct or not? So you have done some project on this onto this. Now coming to the telemetry, telecommand. So what is this one? You need to communicate with the satellite. What is happening on the satellite? Whether it is on the orbit, or whether it is deviating from its position or not. Okay. So this all information will be coming from satellite health. Everything will come from the telemetry and telecommand system. Then you have an onboard computer which is used for the flight software. Whatever data you are sending has to come to the telemetry and telecommand system. No? So these all things are handled by the onboard computer. Whatever data you are sending from the ground and whatever data you are receiving to the ground, all will come through onboard computer. Then you have a attitude determination and orbit control system, USES system. Okay. So this USES is required for the attitude determination. Now what will happen? Due to various forces acting, the satellite will not be moving. A satellite over the time will drift from its intended position in the orbit. So you have to keep controlling that one by using different thrusters or motors, whatever you use. So that is what is part of the attitude and orbit control system. So there is a thermal control is there. Now let us suppose there are different areas when it is going, when the satellite is moving, it will encounter to different temperatures. Sometimes it may, when it is near the equator, it will experience high temperature. When it is going to the poles, it will experience a low temperature. Correct or not? So to have control of all these things, you will have a thermal control system. Where the satellite is going, accordingly, you will have different mechanisms in place to do this one. And you will have a structure and a mechanism. So, how you will keep the entire things as a structure, which you are putting onto the satellite bus, the payload. This is where your structure is required, correct? And how you have to deploy something when something has to be deployed. So, there is a propulsion is there, so which will take you to the orbit, and how any orbit control system if you have to make, you need thrusters which will keep the orbit in place, all these things. These all comes under propulsion. So this is what you study in any book. But how you understand, that is only the thing which will come here. So I am happy to see all the 7 systems are covered into the projects what morning I have seen. So whether you might have understood it in this way or not, I have seen somebody has done electrical power system for the satellite. Can somebody stand? Who are the group?
Kartikeya team.
Kartikeya.
Kartikeya team.
Okay. So the electrical power system is what we have done. Now the telemetry and telecommand. Somebody is receiving the telecommand and telemetry. I have seen somebody has done this thing.
Spurti.
Which team?
Spurti and team.
Here.
Okay. So they have done that one. Somebody has done the onboard computer. This also I have seen.
Okay. So that.
Okay, no problem. Okay. There is somebody has done the onboard computer.
Maheshwari and team.
Now somebody has done the attitude and orbit control. Of course, this also comes into this thing. So they have done this.
So your team. This people have done onboard computer. This people have done ADCs.
Fine, excellent. Now thermal is one area, and maybe in the deployment you have taken some temperature based thing. How you are using that thing and it is getting deployed. Correct or not? Somebody has done, I think, onto the thermal also some solar panel, all those things somebody has done. Now structure and mechanism, this deployment mechanism, somebody has done.
Adarsh, Vikshita team.
Correct? Now, there is a propulsion is a different one, which is mostly of a mechanical related, which normally. So, if you see here, now you might have understood the power of the force what sir has here. So, I am very glad that all the things are covered of the satellite bus, what we have done it. And there is a software thing is there, of course, for each of these things. Different software and firmware mechanisms are there. So I must congratulate you. Now you have understood now. Without knowing that you are building a complete satellite system, here itself you have made a mini satellite. Correct or not? So this will be a foundation for you to do your bigger things. Okay. So each and every aspect of this one is covered. That's why I felt very happy when I have seen this thing. Okay. Now coming to the satellite payload. Okay. Now you have done through satellites. Correct or not? This is part of the satellite which is called a satellite bus. Now you are seeing the payload. Payload is which makes the satellite and all. Okay. So what it is carrying? So if you see the carrier as a satellite, once it is taken, the launch vehicle has taken it, the mission why it is existing. That is what is called the payload. Okay. So why this satellite is launched? For what application this is launched? That thing you have to keep onto the satellite, no? Correct or not? Okay. So satellite bus is like your car or whatever you want to do. Okay, it is a launch vehicle which will take you to some vehicle. You have a launch vehicle which will keep the satellite onto the orbit. Once you go onto the orbit, what you have to do once you reach there? So that is decided by the payload. Okay. So what kind of antennas you are keeping, what kind of RF subsystem you are keeping, what kind of digital subsystem you are keeping, how you are processing the data which is coming, these are all part of the payload. So which will change with the mission always. Correct or not? So if you see as a satellite bus and payload, this is very important to understand. So if you see why satellite bus will keep the satellite alive, powered and pointed. So what is meant by satellite alive means it should be in the orbit. Correct or not? If it is deorbited, it will not serve the purpose, you will not get the required coordinates what you are doing. Now it should always be powered. Correct or not? To get that. And it should be pointed. You want to see this area, you have to see that area. You need not see the other area. Correct or not? So that is why pointing is required. Satellite payload will deliver the mission. Why it is required? That is what I am doing. Coming to this thing, these are these satellite bus subsystems, power, telemetry tracking. And you have a satellite payload which may consist of a transponder, a camera, a sensor, antenna, radar, electronic warfare system. It can be anything. Now, once the satellite bus, normally reusability. Okay. So once you make the satellite bus for one orbit, that can be reused for other missions on the same orbit or within the lean orbit or whatever you have taken. Coming to the satellite payload, for every mission you need to define a different payload and you have to keep it. So normally satellite bus will not change with the mission, but payload will always change with the mission. Understood? Now coming to the different subsystems where you can contribute. Okay. Now coming to a communication satellite, I am taking you to a different kind of satellites what are existing. How an electronic person who has studied, how they can contribute to this. Now you will see the entire spectrum of subjects what you study in the college. Now you see transponder. So what a transponder will receive? It will receive the signal what you are transmitting from the ground. You are sending a live feed of this event, let us suppose through YouTube. Okay, it will go through a satellite and it will come back. So it will have a RF transport which will receive the signal, amplify it and translate the signal for the uplink as well as downlink, and it will send it down. Correct or not? So you need a power amplifier because you are sending the signal to a distance of 36,000 kilometers. Now I am speaking here. It is not visible to you at the end. Now if I am using an amplifier which is there in the mic, I am able to reach up to here. Correct or not? So now when you have to reach whatever signal you are sending, it will lose its strength over the time, over the distance. Correct or not? All of you know. So to keep this thing, you require some power amplifier. Correct or not? You require an antenna system to receive the signal. Correct? So you require modulation because you want your data to be sent on a particular carrier and it has to reach there. Correct? So then, since you need to send multiple data over the same channel, you will use different kind of multiplexing. Correct or not? Then you require a stable frequency synthesizers which will require for you to get a proper carrier signal which can take your data onto the satellite and it can come back. Now, if you see where you can contribute. So there is different RF and micro circuits are there in the transponder. You have different antennas are there. Then you have a software defined radio, which may be a particular kind of onboard computer what we have done. Then you have a ground station receiver you have to design. Correct or not? So there are different areas all are required to make a complete satellite. If you see a satellite as a bigger project, there are different areas where each person will contribute in each of these areas. Now, if you see a navigation satellite, so you can use a GPS or GNSS receiver using the offshore model. There is a GPS receiver, that's what you have done it. Okay. Now, you study the embedded firmware for the GNSS chips, how the embedded thing is coming onto this thing. What is the kind of logic which I need to write to understand this data. Now the signal processing, how you need to process the signal which is coming. So these all are common areas in each of these things. Okay. So whatever you see of different subsystems in a remote sensing satellite, if you see, so if you are using it for a image processing, so you might have studied different image processing techniques in your college. Image processing,
7 semester course.
sensing. Okay, fine. So somebody might have studied. Okay. Now you have to, once you are processing the data and it has to come in real time. Okay. You need to use FPGAs or real time process where you will process the entire spectrum of data in a FPGA. Like I will ask you one question. You are using different microcontrollers, microprocessors,
Yes, sir.
FPGAs,
Yes, sir.
ASICs.
Yes.
So where all these things are fitting their space. Can anybody tell why? Once let us suppose you have a microcontroller, you have a PC here. Okay, you can run the entire code into this thing and show on the PC. Correct or not? Once you have a PC, why you require FPGA? Why you require ASIC? Can anybody tell? Or once? Can you tell? Processing time, exactly. Excellent. What else? Stand up and tell, no problem.
Yes, sir. I also wanted to show you some project. Now you can.
Somebody, I'm hearing the voice. Where from it is? Okay, fine. Tell me. Processing power in terms of computation. Correct? So, if you understand it like that, so if you see any processor, okay, why I am emphasizing on this point is, if you know this thing, you can apply in different areas, not only in the space, in defense, anywhere. Okay? Any processor, if you say, it works sequentially, instruction by instruction, one instruction at a time. Correct or not? When you go to, whether it is a multi-core processor, 1 core, 20 core, whatever you say, ultimately it is a sequential processing. What will happen? So these cores may operate in parallel, but it is a sequential processing. Okay? Now once you say in an FPGA based thing, what you are calling it as field programmable. What is field programmable? So you are writing some code onto this thing, correct or not? And you are putting onto a processor. Is it not field programmable? Why only FPGA is called field programmable? Why microcontroller is not called a field programmable? Can anybody? So why I am not trying to put you into this thing. Normally, as a student level, how you have to understand the subject. This is what I am trying to correlate this thing. When you say any microprocessor, any microcontroller, or any processor for that matter, okay, it is also reconfigurable. Correct or not? You can change the code and you can rerun it. But why FPGA only is called field programmable is the circuit in the microprocessor. What are the different subsystems you have? You have a memory, you have a processing unit, correct or not? What else? You have different bus, data bus, control bus, all those things are there. So the difference is in any processor, if you see the communication between the main processing unit and the peripherals is fixed. You cannot change it. Okay? When it comes to FPGA, you are not only changing the software, you are changing the hardware also. You have different blocks are there. I have a signal processing unit here, I have a arithmetic logic unit here, I have a DSP block here, and I have a memory here. This connection is not fixed. So you can connect anywhere to anywhere based on your application. That is where the FPGA will come into picture. So once your logic is prototyped and proven and you want to use it for multiple applications without changing anything, then you will make an ASIC, which is called an application specific integrated circuit. Correct? So this is where it is going into the silicon where your higher clocks are possible. How much time I have? Huh? 20.
How much time?
I can speak, not like that. Okay, you put as per your thing. I will
Lunch
adjust.
break.
Okay, fine. No problem.
We will go to the class session.
Fine, fine. Okay.
Shall I cut the?
Fine. We cut it. Just before that one.
Okay. Yeah.
So I will throw some light of why space is different from other electronics. Just I will throw into this thing. So when whatever components you are using here, the components will not work in the space. What you are using in the cell phone, what you are using in the processor, what processor you are using. So it should be radiation hardened because there the radiation is there in the space. So the component should work into that environment. So you require a special components. So what we will do is, we will do into the vacuum testing whatever are required. How you will do all these things into the testing. There are some specialized components are there which will work into the space. You need to select the components and then you need to use a zero maintenance because there is no maintenance, there is no scheduled maintenance. After 3 months you do some servicing, not like that. Correct or not? And you should have a strict power and mass budget because circuit has to work for that purpose. So this is what is different from other places. I will leave the presentation for you. Now designing for the impossible. So this is mainly the space system design philosophies. When you are doing this thing, space design, you can cut off, sir. I will go into that.
I will. Madam, Karthikeya.
Kartikeya.
Cut the YouTube. With the confidence. Cut the YouTube.